Hello, children. Welcome to Right Tuition Classes. We are doing Theorems of Circle chapter, chapter 3, Theorems of Circle chapter. Now, the first theorem, what we're going to learn is a tangent theorem. Now, this theorem, tangent theorem, we're not going to learn the proof of it, children. The proof of it will not be asked. Are you getting me? Some years back, it was considered a very important theorem proof was asked in the board exam, but now of late 10 years it has been not asked. But this theorem, what does it mean? Okay, let's try to understand. A tangent at any point of a circle. Tangent at any point of a circle is perpendicular to the radius to the point of contact. You can see here, let's see here. O is the center of circle, line L is tangent at point A. But A is the point of contact. So the moment they say line L is a tangent, this moment they say line L is a tangent, at once it should come to your mind. What should come to your mind, children? Line L is tangent. Therefore, segment OA is perpendicular line L by tangent theorem. Name of the theorem is tangent theorem. By tangent theorem. I don't have place, but I'm just trying to adjust. Okay. So the moment you see a tangent, what should come to your mind? Especially only one tangent in the question given, this idea should come to your mind. It's perpendicular to the radius. Like if I draw radius OA, this OA, radius OA is perpendicular to line L. Radius OA is perpendicular to line L. Radius OA is perpendicular to line L. Are you getting me here? Likewise, line P is tangent to the circle. Line P is tangent to the circle at A. So what should come to your mind, children? Again, you can see here, children, line P is tangent to the circle. What is given? Line P is tangent to the circle. Tangent to the circle, okay, to the circle. So what should come to your mind? Therefore, segment OA, perpendicular line P. And what should be the reason, children? By tangent theorem, by tangent theorem, by tangent theorem. Again, children, line M is tangent to the circle at C. Well, the C is the point of contact, okay? So what should come to your mind? Like line M is tangent to the circle, to the circle at C, okay? But the C is a point of contact. So what should come to your mind? Segment OC, perpendicular line M by tangent theorem, by tangent. The name of the theorem is tangent theorem. You don't have to worry about the statement and all. But the moment you see a tangent, tangent is perpendicular to the radius should come to your mind. Tangent is perpendicular to the radius. Segment here, OC, perpendicular line M. Okay? Segment OC, perpendicular line M. Here, children, just have a look here. Again, children, here what is given? Line XY is tangent. Line XY is tangent. Line XY is tangent at P. So what should come to your mind? Therefore, angle OPX equal angle OPY equal 90 degree. Perpendicular means the same. It makes an angle of 90 degree. Okay. So I just show it as 90 degree. And that reason should be by tangent theorem, by tangent theorem, by tangent theorem. Are you getting me here, children? Here, again, children. Segment OA, see line PQ is tangent. Line PQ is tangent at A. So what should come to your mind, children? Therefore, angle OAP equal angle OAQ equal 90 degree by tangent theorem, by tangent theorem, by tangent theorem. That means one thing is very clear. So many examples I showed you. The moment you see a tangent, what should come to your mind? It's perpendicular to the radius, okay? Or it makes an angle of 90 degree with the radius. Are you getting me? The moment you see a tangent, what should come to your mind? But it makes an angle of 90 degree with the radius. Are you getting me? So remember, children, abhi se tangent dikha. So you have to say tangent is perpendicular to the radius. In short, okay, you can call it as tangent theorem. You can call it as tangent theorem. I hope everybody has got this theorem, children. No proof of it. लेकिन अभी से जब भी सर्कल में एक टैंजेंट रहेगा तो आपके दिमाग में आने चाहिए इट्स परपेंडिकुलर टू द रेडियस एट द पॉइंट ऑफ कांटेक्ट। थ्योरम का नाम है टैंजेंट थ्योरम। थ्योरम का नाम है टैंजेंट थ्योरम। Now, the next theorem, theorem number two, converse of tangent theorem. A line perpendicular to the radius of the circle at its outer end is a tangent to a circle. A line perpendicular to the radius of the circle at its outer end. Matlab, suppose this is line L. I don't know whether it is tangent or not, but when I draw a radius of it, okay, and the radius of it is, suppose the radius of it is OA, okay? The radius of it is OA. The radius of it is OA. So which is the outer end of the radius? O or A? A is outer end. Got it? Outer end of the radius. Huh? A is the outer end of the radius. So अगर ये line tangent है क्या नहीं मालूम, करेक्ट। लेकिन अगर if this line L is perpendicular to segment OA at point A, outer end A, got it? Then line L is a tangent. Line L is a tangent. I hope everybody understood it. Okay, like line L tangent है क्या मालूम नहीं, पूछ रहे हैं how can I show that? अगर OA का साथ लाइन एल परपेंडिकुलर रहेगा एक ऊपर तो हम लाइन एल को टैंजेंट बोल सकते हैं। और एक एग्जांपल, जैसा लाइन PQ है, is line PQ a tangent at A? Is line. So again, if, please have a look here, if this is OA, if, okay, line PQ is perpendicular to segment OA at point A, then I can say line PQ is a tangent by converse of tangent theorem. Is a tangent by converse of tangent theorem. In the same way, suppose this is line M, this is B. Got it? Is line M a tangent? So if you see, or line M is perpendicular to segment OB at point B, then I can say then line M is a tangent to the circle at point. Line M is a tangent to a circle, okay, by converse of tangent theorems. तीनों का reason by converse of tangent theorem. I hope everybody understood me here. A line perpendicular to radius of the circle at its outer end is a tangent. Now we go to the next theorem. Theorem number three, children, it's tangent segment theorem. Now, what is a tangent segment? Let's try to understand and then try to understand the theorem. Suppose from an external point P, you can see two tangent lines can be drawn. One is line PA, other is line PB. So from an external point, P is an external point of the circle. So from an external point, two tangent lines can be drawn. Suppose this external point and this line is tangent at A. So this part of the tangent line, okay, the part of the tangent line which is drawn, okay, or which is drawn, I'll put it like this, from an external point to the point of contact, okay, from an external point to the point of contact. This part is called a tangent segment. This red part is called a tangent segment. This red part is called a tangent segment. Again, I repeat, the part of the tangent segment from an axial, like Q is an axial point, okay? This is tangent till at R, okay? This line is tangent at R. So from Q to the point of contact, okay? From S is a point of contact. So from Q to the S, this is a tangent segment, okay? This is a tangent segment. So I hope people are getting me here. Like M is an external point from M till N, okay? This tangent at N, this tangent at N, okay? This tangent at N. And this is again a tangent at P, okay? From M, tangent at P. So you can see all the shaded, thick shaded segments, what I shown you, okay? What I shown you. P is an external point from P. Please have a look here. From P, Okay, the tangent line PA, it's tangent at A. Okay, but from P to the point of contact A, what is this called a tangent segment? From P to the point of contact B, this PB is called a tangent segment. From Q to the point of contact R is called a tangent segment. From Q to the point of contact S is a tangent segment. From M to the point of contact N is a tangent segment. From M to the point of contact P is a tangent segment. Now let's see the theorem. What it says, the length of the two tangent segments drawn from an external point to the circle are equal. Like you can see here, PA and PB are the tangent segments drawn from an external point to the circle. These two, PA and PB, are equal. The theorem says PA and PB are equal. The moment you see something like this, QR equal QS, okay? Here the tangent segments are QR and QS. So QR equal QS by theorem of tangent segments or tangent segment theorem. Like MN equal MP, tangent segment. So remember, the moment you see a tangent segment drawn from external point to the circle, it should come to your mind. They are equal. They are equal. The length of the two tangent segments drawn from external point to the circle are equal. This is called tangent segment theorem. What is it called? Tangent segment theorem. Now we go to the next children. We see now this theorem is asked in your exam. The proof of this theorem is asked in your exam. See the form in which it is asked. Okay. See the way it will be asked in an exam, board exam. Prove that the length of the two tangent segments drawn from an external point to the circle are equal. The length of the two tangent segments drawn from external point to the circle are equal. So I told you a trick, children. Either is या are. ये plural में दो tangent segments involved है, इसके लिए are है. ये आर का पहला आपको मिल जाता है गिवन, मतलब आपको क्या ड्रॉ करना है, द टैंजेंट सेगमेंट्स फ्रॉम एन एक्सटर्नल पॉइंट टू द सर्कल. मतलब मुझे क्या ड्रॉ करना पड़ेगा, प्लीज हैव अ लुक हियर. आई हैव टू ड्रॉ a tangent. First I'll have to draw a circle. Okay, I'll have to draw a circle. Then I have to take one external point. Please have a look here. I'll mark one external point here. Suppose I mark one external point P. I draw a circle with center O. I draw an external point P. Now you can see here, children, from this external point, I can draw two tangent segments. One is PQ is a tangent segment. PQ is a tangent line. Two tangent lines I can draw. Okay, I'm drawing a tangent line right now. You can see here, I'm drawing a tangent line. Okay, right now I'm drawing a tangent line. Right now I'm drawing a tangent line. So I've drawn the tangent lines. Okay, right. You can see here, children. I called it as a line. Okay, you can see it goes on extending, starting from P, but it goes on extending. PA and PB are the tangent lines. Okay, now from P to A, this portion is called a tangent segment. From P to B, this portion is called a tangent segment. And what you have to do is you have to show this tangent segment drawn from an external point to the circle are equal. You have to show these tangent segments drawn from an external point to the circle. This PA and this PB, you have to show they are equal in length. This PB are equal in length. But how can I show, children? Got it? So see here, children, I want people to pay attention here nicely. This is very simple and has chance of getting asked in an exam. Here, children, given. क्या आएगा? Prove that the length of the two tangent segments drawn from axial point to the circle are equal. Means I have drawn the two tangent segments from an axial point to the circle. I want to show they are equal. So given the first thing, the figure is here, children. The figure I've shown you here, but listen, given is what? Given, I'll say a circle with center O. A circle with center O. A circle with center O. What else is given, children? From an external point P, from an external point P, segment PA and segment PB are tangent segments. Okay, this all are drawn. Okay, this is given to you. And what you want to prove? Prove that the tangent segments drawn from an eggshell pond to the circle are equal. You want to prove this PA equal PB. PA equal PB. Now, just think, children, how will you show two segments equal in length in geometry? Okay, you're not going to measure it with a scale and show me they are equal. So, what is the other way? I just show the segments congruent. ये दोनों segments congruent हो गया, तो I can say they're equal in length. लेकिन how to show the segments congruent? How to show the segments congruent? Segments can be shown congruent, children, very easily. You can see the red segment, it belongs to this red segment, it belongs to a red triangle. You can see here this red segment belongs to the red triangle, children. Okay. And in the same way, this blue segment, it's a side of the blue triangle, children. It is a side of the blue triangle. You can see this red triangle and the blue triangle, children. And now, so simple, children. Don't you agree? These are tangents. So the very first theorem, tangent is perpendicular to radius. By tangent theorem, this angle is 90 degree. This angle is 90 degree. Okay, OAP is 90. Likewise, OBP is 90. That means this red triangle and the blue triangle are right angle triangles. And do you realize ये रेड ट्रायंगल का हाइपोटेन्यूज ओपी है, ब्लू ट्रायंगल का हाइपोटेन्यूज भी ओपी है, हाइपोटेन्यूज ओपी कॉन्ग्रुएंट हाइपोटेन्यूज ओपी. What is the reason, children? The reason is common side. Hypotenuse OP congruent, hypotenuse OP common side. And don't you realize segment OA is congruent to segment OB, radii of same circle. So what you see, hypotenuse on the side of the red triangle is congruent to hypotenuse on the side of the blue triangle. That means both the triangles are congruent by hypotenuse side test. Triangles are congruent, triangles are congruent, triangles are congruent. मतलब दोनों ट्रायंगल एक के ऊपर एक फिट होगा. फिर पीए का सब कौन सा साइड फिट होगा? पीबी फिट होगा. Corresponding sides of congruent triangles. So PA congruent PB corresponding sides of congruent triangles. ये दोनों congruent हो गया. So can I say PA equal PB? So we're going to write the same proof of it. So before that construction, children, because what I did, this construction, only tangent segments are there. So you drew OA, OA, OB, OP, and OB. So draw, please have a look here. Draw segment construction should be with dotted line. I cannot show it in dotted line here. Please try to understand, okay? Compulsory construction OA, OP, OB should have been in dotted line. Draw segment OA, segment OP, and segment OB, okay? Now prove, children. You see, these two triangles, I want to prove them congruent. Whenever you want to prove triangles congruent, you start with this. In triangle OAP and triangle OBP. Okay, we started with the names of the triangles. Now, by what test we have proved them congruent? Hypotenuse side test. Hypotenuse side test का special way है. पहला हमेशा 90 degree angle दिखाएंगे. In triangle OAP and triangle OBP show the 90 degree angle. Angle OAP equal angle OBP equal 90 degree. Reason is by tangent theorem. Tangent is perpendicular to radius by tangent theorem. Okay. So now what happens? The reader understands that ये दोनों triangle right angle triangle क्योंकि उसका angle 90 degrees है और क्योंकि उसका angle क्या है 90 degrees है. So right angle triangle the reader understands. Now this right angle triangle है तो उसमें hypotenuse होता है. So I look at hypotenuse OP and hypotenuse OP of the other triangle also. And I realize this hypotenuse is a common side for both. Common side, hypotenuse are congruent. That means common side, okay? Is one more side congruent? Yes. Segment OA is congruent to segment OB, children. The reason is radii of same circle. Radii of same circle. Radii of same circle. Radii of same circle. So naturally, children, आप क्या दिखा रहे हो? Hypotenuse on the side of one right angle triangle is congruent to hypotenuse on the side of other right angle triangle. So I can say triangle OAP congruent triangle OBP by hypotenuse side test by hypotenuse side test by hypotenuse side test by hypotenuse side test. Okay, if both the triangles are congruent, that means they fit to each other. So PA का सब कौन सा triangle side fit होगा? PB. So can I say therefore segment PA congruent segment PB? I'm writing it in short. You better don't write it. CSCT, corresponding sides of congruent triangles. Okay, and if they are congruent, can I say therefore PA equal PB? So naturally now onwards, did you understand length of the two tangent segments drawn from an external point to the circle are equal? It should come to your mind. The moment you see the tangent segments are equal, the proof of this, prove that is a question board में आ सकता है. Correct, children? We go to the next theorem, children. Before I go ahead with the other theorems, children, I would like to teach you some concept. Okay, a circle, you know what it is. Now look at this part of the circle, children. Can you see the brown part, the red part, the blue part, the green part? This part of the circles are called arcs of a circle. What are they called? Arcs of a circle. So every arc you can see has an endpoint. Every arc has an endpoint. Every arc has an endpoint. Okay, you can always name these endpoints like A and B. I can call this with a two-letter name right now. I can call it arc AB. I can call this as a two-letter name, arc CD. I can call this as arc PQ. I can call it as arc RS. So I hope people understood what is an arc of a circle. A part of a circle is called an arc of a circle. Now, after telling you this, come to the next figure, children. This was the first figure. Now I'm coming to the second figure. Now look at this AB segment. It passes through the center O. So AB is called a diameter. AB is called a diameter. The diameter of a circle divides a circle into two equal arcs. One is brown arc and the other one is this blue arc. Okay, both these arcs, okay, you can see here, diameter circle divides a circle into semicircular arcs. Can you see the brown arc? And this, they are called semicircular arcs. They are semicircular arcs. Diameter circle divides a circle into two arcs. They are called semicircular arcs. So, semicircular arc, I better name it a three-letter arc. One arbitrary point in between, I'll put X. I can call it as arc AX, V of BXA. Same way here, I can put Y. I can call it as arc AYB of BYA. Are you getting me here? See here, children, I hope everybody understands. See, when I say how to name an arc, arc can be named with the help of two letters, arc AB. A, small r, small c, arc, small a, small r, small c, arc PQ. Got it? Likewise here, I can name this semicircular arc as arc A small a, RC, A arc AXB, small a, RC, arc AYB. They are semicircular arcs. They are semicircular arcs. Okay. Now look here, children. This brown arc, got it? I call this. Don't you agree? It's smaller than a semicircle. You can imagine a semicircle. You can imagine a semicircle arc. It is smaller than a semicircle arc. Such an arc is called a minor arc. Such an arc is called a minor arc. Look at this yellow arc, children. It is bigger than a semicircular arc. एक semicircular arc ऐसा आएगा, okay? Semicircular arc, yellow arc is bigger than a semicircular arc. It is called a major arc. Cool? Please have a look. It is called a major arc. Okay, children. Okay. Now, this minor arc, you can always name it with the help of two letters. You can say mine arc AB. You can arc AB. But a major arc, you better name it with a three-letter name. Okay, one arbitrary point somewhere in between. You can always call it as arc AXB. A major arc should be named with the help of three letters. A minor arc can be named with the help of two letters. Or if you see anywhere an arc has been named with the help of two letters, it is a minor arc. I hope everybody understood. Once again, I'll just repeat in my figure number one. This is figure number two. This is figure number three. The figure number one, I just told you, children, an arc is nothing but a part of a circle. An arc is nothing but a part of the circle. So all this brown part, red part, blue part, green part, they are parts of the circle. They are arcs of a circle. Every arc has an endpoint. Every arc has arc has two endpoints. So I can always call it as arc and name it as help of the endpoint. Arc AB, arc AB, arc BC, okay, arc CD, arc PQ. Got it? I can name it with two-letter name. Are you getting me here? Got it. Now let's see here. The second figure, children. A diameter of circle I have drawn. It divides a circle into two equal arcs. Each of these arcs are called semicircular arcs. And if I had to name a semicircular arc, I better name it with the help of three letters. Arc, and this X somewhere in the arc, okay? RKXB, arc AYB, RKXB, arc AYB. Now look at this brown color arc. It is smaller than a semicircular arc. Such an arc is called a minor arc. It has to be named with the help of two letters only. It has to be named with the help of two letters only. Now, look at the yellow arc. Children, it's bigger than a semicircular arc. So this yellow arc is a major arc, and it has to be named with the help of three letters like R, K, X, B. You cannot name a major arc with the help of two letters. Okay? After this three, I go ahead, children. I say every arc has an angular measure. Every arc has angular measure, just like angles का measure होता है 30 degree, 40 degree, 50 degree, 60 degree, 70 degree. We say every arc has a measure. So let's start with the minor arc. Okay, what is measure of a minor arc? Like RKB is a minor arc. Okay. So first, before that, I should tell you what is the central angle. The angle at the center circle is called a central angle. Angle at the center circle is called a central angle. Angle at the center of circle is called a central angle. This angle AOB is a central angle. Now what I'm saying, just have a look. With every minor arc, we can associate a central angle. With every minor arc, I can associate a central angle. Just RKB. If I join the endpoints of A and B to the center, angle AOB is a central angle for RKB. If I join S2O center, R to the center, got it? Angle SOR is a central angle for arc SR. Every minor arc can have a corresponding central angle. A minor arc and its central angle. Just have a look. So for this minor arc AB, I can call AOB as a corresponding central angle. मतलब every minor arc का साथ एक central angle होता ही है. And now remember, children, what I'm saying, a very important statement I'm going to write. Just have a look at this statement, children. A measure of a minor arc, a measure of a minor arc, measure of a minor arc is always equal to measure of its corresponding central angle. Measure of its corresponding central angle. Measure of its corresponding central angle. For example, this central angle is 70 degree, then measure of KB is 70 degree. This central angle is 80 degree, measure of KB is 80 degree. Central angle is 40 degree, measure of KB is 40 degree. Central angle is 120 degree, measure of KB is 120 degree. So remember, a measure of minor arc is equal to measure of its corresponding central angle. Corresponding central angle. Okay, children. Then second point, remember, measure of एक सर्कल है ना, पूरा सर्कल 360 डिग्री होता है. measure of a circle is 360 degree. अरे पहला भी बोल सकता था, नहीं मंगतर का भी बोला. Now look, for this RKB, which is a corresponding major arc AXB, for minor arc AB, which is a corresponding major arc AYB. Now I want measure of a major arc. Measure of a major arc is always equal to, children, 360 degree minus measure of its corresponding minor arc. Measure of its corresponding minor arc. Corresponding minor arc का measure तो निकाल सकते हो central angle का मदद से. इसके लिए okay, corresponding minor arc. Okay, so remember, children, measure of a major arc is 360 degree minus measure of its corresponding minor arc. Okay, now remember one more thing. Measure of a semicircular arc. Measure of a semicircular arc. Measure of a semicircular arc is equal to, children, 180 degree. So remember these 4 points. Okay, the measure of a minor arc is equal to measure of its corresponding central angle. Measure of a circle is equal to 360 degree. Measure of a major arc equal 360 degree minus measure of its corresponding minor arc. And measure of a semicircular arc equal 180 degrees. So I hope people understood about an arc. I just wanted to give a concept about an arc, okay, so that you can understand the theorems better. We go to the next theorem number 4, children. We go to the next theorem, children. Theorem number 4. We go to the next. What the theorem says, theorem number 4, in a circle, मतलब एक सर्कल में और इन कॉन्ग्रेंट सर्कल, जैसे ये दो सर्कल कॉन्ग्रेंट सर्कल है बेटा, दोनों सर्कल का रेडियस इक्वल है, समझो एक छोटा एक बड़ा दिखता है, रफ फिगर है, लेकिन दोनों का कॉन्ग्रेंट सर्कल्स, ये दोनों कॉन्ग्रेंट सर्कल्स, ओके चलो, सपोज दिस आर कॉन्ग्रेंट सर्कल्स एंड arcs are, you have arcs congruent arcs are there, like RKB और आर्क सीडी दोनों एक ही सर्कल का है और दोनों का अगर मेजर इक्वल है मतलब दे आर कॉन्ग्रुएंट, ओके, तो दोनों आर्क कॉन्ग्रुएंट है, दोनों आर्क कॉन्ग्रुएंट है, दोनों आर्क कॉन्ग्रुएंट है, ओके, दे आर कॉन्ग्रुएंट, मतलब this arc, please have a look at this arc AB and this arc CD, they are congruent. In the same way, okay, like suppose these are congruent circles. This arc AB and this arc PQ, yeah, CD, they are congruent. Okay, that is what the theorem says. Suppose this arc AB and arc CD are congruent. This arc AB and arc CD are congruent. Okay, arc AB and arc CD are congruent. Arc AB and arc CD are congruent. Children, arc AB, and arc CD are congruent. So here, either same circle में arcs are congruent, या congruent circles में arcs are congruent. When you see this, arc AB is congruent to arc CD. If you see like this, you can always say, got it? If arc AB congruent to arc CD, then you can always say by this theorem that have their corresponding chords congruent. Look here, AB, if I join this AB, children, AB is a corresponding chord of arc AB. CD is a corresponding chord of arc CD. So if arc AB congruent arc CD, then at once you can say, children, then chord AB congruent chord CD, chord AB congruent chord CD, got it? Chord AB congruent chord CD. Even suppose these are congruent circles, okay? These are congruent circles. These are congruent circles, children. Okay, you see the arc AB and arc CD are congruent. Then immediately you can say chord AB is a corresponding chord of arc AB. CD is a corresponding chord of arc CD. If arc AB congruent arc CD, I can say chord AB congruent chord CD. So remember this theorem, children. Either in the same circle, if the arcs are congruent, then the corresponding chords congruent. In the congruent circles, if the arcs are congruent, then the corresponding chords are congruent. Are you getting me, children? So in a circle, congruent arcs have their corresponding chords congruent. Congruent arcs have the corresponding chords congruent. I hope everybody understood it like a theorem, children. Now suppose it comes in your exam like a question. In your exam, it comes like this. Prove that in a circle or in congruent circles, congruent arcs have their corresponding chords congruent. In a circle or in congruent circles, either you take one circle or you take congruent circles, your choice. Congruent arcs, मतलब arcs congruent है. You have to show they have their chords congruent. Got it? That means, please have a look here. I'm going to draw one circle, okay? I'm going to draw one circle, okay? I'm going to draw one circle, okay? Now, in this circle, I'm going to have, please have a look here. I'm going to have chords congruent. I'm going to have some chords congruent, okay? I'm going to have some chords congruent, okay? You can see, I'll just show it to you. This arc, suppose this arc AB, okay? And arc and see your children, a circle with center O, and this arc AB and this arc CD are congruent. So what is given to us is a circle with center O, a circle with center O, circle with center O, circle with center O. And what else is given, children? This arc AB is congruent to arc CD. What is given? Arc AB is congruent to arc CD. This arc AB and arc CD are congruent. This arc AB and arc CD are congruent. And what they want is to prove that in a circle or congruent circles, congruent arcs have their corresponding chords congruent. We want to prove that corresponding chords are congruent. So you can see here arc AB का corresponding chord AB है, arc CD का corresponding chord CD है. We have to prove these chords are congruent. You have to prove these chords are congruent. You have to prove chord AB मतलब segment AB. Okay, as chord is a segment. Okay, segment AB congruent segment CD. You have to prove these segments are congruent. Now, how to prove a segment congruent, children? Very simple. A segment is always a side of a triangle. Segment can be a side of the triangle. So, agar identify a triangle whose side AB is, identify a triangle whose side CD is. No triangles are there, but I can base construct. I can join O to A, so I get one O and O to B, so I get one triangle. I join O to C and I join O to D, I get the second triangle. Can you see the two triangles? Now, if these triangles are congruent, then I can say AB congruent CD, children. So simple. How can I show the chords congruent? So you can see in this triangle, okay, OA is congruent to OC, radial same circle, OB is congruent to OD. तो दो ही इंफॉर्मेशन है, तीन इंफॉर्मेशन चाहिए. लेकिन जब भी तीन इंफॉर्मेशन चाहिए, प्लीज हैव अ लुक हियर. आपको गिवन इंफॉर्मेशन ही हिंट है. तो गिवन क्या है बेटा? Anyhow, first 1 minute, we write construction. What did it draw? Segments. We drew segments OA, OB, OC, and OD. Okay. Now, proof. Please have a look here. Yeah. I told you I want to prove the triangles congruent. Triangles को prove करने के लिए congruent तीन information का जरूरत है. मेरे पास खाली दो है इधर. तीसरा किधर है? Always for getting the third information, given information is a hint. What is given? अरे arc AB congruent arc CD. Arc AB congruent arc CD means they have equal measure. So what is given? Measure arc AB equal measure arc CD. But what do you know about measure of an arc? I taught you measure of a minor arc is always equal to measure of its corresponding central angle. Measure of a minor arc is always equal to measure of its corresponding central angle. मतलब measure arc AB will always be equal to angle AOB. Okay, measure arc CD will always be equal to angle COD by definition of the reason that statement. Measure for minor arc is equal to measure of its corresponding central angle. This is called definition of measure of minor arc. By definition of measure of minor arc, by definition of measure of minor arc, by definition of measure of minor arc. Okay, children? But don't you agree? But measure arc AB is equal to measure arc CD. But measure arc AB is equal to measure arc CD, children. Statement number 3 given है. तो याद रखो फ्रॉम थर्ड स्टेटमेंट आपको समझ में आ रहा है लेफ्ट हैंड साइड ए बी और सी डी इक्वल है मेजर ऑफ ए बी और सी डी सो नेचुरली द राइट हैंड साइड विल आल्सो बी इक्वल therefore angle AOB equal angle COD can I say from statement number 4 from 1 2 and 3 from 1 2 and 3 now after getting these angles equal now please look at the triangle in triangle AOB and triangle COD, OA congruent OB, OC, radius of same circle, AOB congruent COD, from 4, OB congruent OD, radius of same circle, अरे triangle AOB congruent triangle COD by SAS test. अगर दोनों triangles congruent है मतलब दोनों triangle fit हो रहा है तो AB का सब कौन सा side fit होगा बेटा CD say AB congruent CD that is called AB congruent chord CD got it so I can easily say so in triangle, I can easily prove the triangles congruent in triangle OAB and triangle OCD. In triangle OAB and triangle OCD, okay? Segment OA, congruent segment OB, OC. What's the reason, children? Radii of same circle. Radii of same circle. Radii of same circle, okay? Then, children, angle AOB is congruent to angle COD. What's the reason, children? From 4. We have got this was missing. We got it, okay? From 4. Then segment OB, congruent segment OB, congruent segment OD. What's the reason, children? Radii of same circle. Radii of same circle. Okay, children. Therefore, triangle OAB, look at these two triangles. Triangle OAB, congruent, triangle OCD by SAS test of congruence, by SAS test of congruence. Now, therefore, segment AB, congruent segment CD, for the reason, children, CSCT, corresponding sides of congruent triangles. So now you can see in a circle, congruent arcs are their chords congruent. Okay, children, we go to the next. Now, theorem number 5, children, a converse of it. Earlier, the arcs were congruent, so the corresponding chords are congruent. Now, what they say, the chords are congruent, the corresponding arcs are congruent. Well, in a circle or in congruent circles, congruent chords have their corresponding arcs congruent. Okay, so the same, just like the previous one, what am I going to do is I'm going to take the same circle. Okay, example of same circle, and I'm going to take the congruent chords congruent. Can you see this chord AB? And this is my chord CD. I take that chord AB congruent chord CD. So what is given to me right now is chord AB congruent chord CD. Okay, circle is center row. And this chord AB and chord CD are congruent. Okay. And what I want to prove, which is a corresponding arc of chord AB, arc AB, which is a corresponding arc of chord CD, arc CD. You have to show this arc AB and arc CD congruent. Okay. So what is given is, please have a look here, a circle with center O. Circle with center O. A circle with center O. Okay. And what else is given? Chord AB, congruent chord CD. Chord AB, congruent chord CD. Chord AB, congruent chord CD. Now, what do you want to prove? You want to prove arc AB congruent arc CD. Arc AB congruent arc CD. When are two arcs said to be congruent? Naturally, if their corresponding central angles are equal, suppose arc AB, we know one thing. This arc AB is equal to angle AOB. We know this arc CD is going to be equal to angle COD. Okay? This arc CD is equal to angle COD. If these angles are equal, I can say the arcs are equal. So arcs are congruent. But how to show the angles equal, children? Alright, I hope people understood me here. देखो बेटा आपको आर्क ए बी और आर्क सी डी कॉन्ग्रेंट दिखाना है. आर्क ए बी और आर्क सी डी कभी कॉन्ग्रेंट होगा जब उनका मेजर ऑफ द आर्क्स इक्वल होगा. इन क्या मेजर ऑफ द, अरे मेजर ऑफ अ माइनर आर्क इज इक्वल टू करस्पॉन्डिंग सेंट्रल एंगल. मतलब मेजर आर्क ए बी इज एक्चुअली इक्वल टू एओबी. मेजर आर्क सी डी इज इक्वल टू सीओडी. तो अगर ये एंगल्स इक्वल हो गया तो यू कैन से द आर्क्स इक्वल. टू शो द एंगल्स इक्वल. Angles को equal दिखाने के लिए look at the triangles. अरे triangles are congruent by, don't you agree, SSS test, children? Look at both the triangles. Okay, we do a construction, of course, to get the central angles. So draw, what is a construction? Draw segments OA, OB, OC, and OD. So I get two triangles. Can you see? Now I'm going to talk about the proof. See, I got two triangles. In both these triangles, you can see, children, they are congruent, by triangle AOB and triangle COD. देखो बराबर. Don't you agree? Segment OA है ना, segment OA. ये triangle का segment OA और ये triangle का segment OC. तो आपस में congruent है. वैसे ही segment OB और segment OD ये भी आपस में कॉन्ग्रेंट है. काहे के लिए? क्योंकि रीजन रेडियस ऑफ सेम सर्कल. Radii of same circle. Radii of same circle. Radii of same circle. Then segment AB. You can look at segment AB iska. And you can look at segment CD iska, children. Segment AB and segment CD be congruent hai. Given hai, children. Given hai. Therefore, can I say triangle AOB is congruent to triangle COD by what test, children? By SSS test of congruence. By SSS test of congruence. ये दोनों triangles congruent हो गया. Therefore, can I say, children, angle AOB congruent angle COD? I take the angles congruent, children. Can I call it children number 1? CACT. Now look at this angle AOB. What is this angle AOB actually equal to, children? Angle AOB is equal to arc AB. Measure of a minor arc is always equal to measure of its corresponding central angle. Likewise, what is angle COD equal to, children? Arc CD. Okay, this are 2, this is 3, and reason by definition of measure of minor arc. Measure of a minor arc is always equal to measure of its corresponding central angle. इसको बोलते हैं definition of measure of minor arc. Measure of minor arc. By definition, a measure of minor arc. But now you can see, अरे बड़ी दोनों central angle equal है, congruent है, one में समझता है. So naturally, can I say therefore arc AB is equal to arc CD, children? Got it? From 1, 2, and 3. 1, 2, and 3. Now listen, these two arcs are equal, but they belong to congruent circle, same circle. Okay, both these arcs are equal, children. Both these arcs are equal. Arc AB and arc CD are equal, and they belong to same circle. They are both the arcs understood. But I'm just writing. Both the arcs belong to same circle. Therefore, got it? Same circle. So if the arcs have equal measure and belong to same circle, I can always say the arcs are congruent. Therefore, arc AB congruent arc CD by definition, okay, of congruent arcs by definition of congruent arcs by definition of congruent arcs, okay, children. I hope people understood me till here. Now we go